Vanish, and I'd like to take a moment to introduce myself. And I've recently joined the 3DCS as the new product director for 3DCS. I've spent roughly 30 years working in the dimensional engineering industry, product development, manufacturing, and product launch. Throughout my career, I've worked extensively with GD&T, dimensional variation, assembly processes, design for manufacturing, and the use of simulation to solve complex and dimensional problems. One of the things that has attracted me to 3DCS is that it brings many of these disciplines together. I've been a long-time believer that dimensional engineering is much more than just GD&T. It's about understanding how design, manufacturing processes, assembly, and variation all work together to deliver a product. As product director, my goal is to help ensure that 3DCS continues to evolve in a way that provides real value to the customers and more importantly, makes it easier for engineers to solve real-world problems. I'm excited about the direction we're taking with 3DCS and about the opportunity to work more closely with all our customers and users around the world. Today, we're going to focus on the new capabilities of the 8.3 release. For each one, I'll introduce the capability and explain why we developed it, and then turn it over to our application engineer, Corey Johnson, who will take you through the demonstration and show you how it applies to your day-to-day work. So with that, let's get started. What we're going to cover today is Drive to Nominal and Copilot. For each one, I'm going to briefly explain why we built it, and then Corey's going to give a live demonstration. Between each introduction, we're going to have a Q&A section, and then we'll move on to the Copilot. So what's going to happen is I'll introduce Drive to Nominal. Corey will have a live demonstration. We'll take a pause, do some Q&A, and then we'll go into Copilot and do the same thing. Before we begin, your cameras are off, and all attendees' microphones are muted. We can post questions in the Q&A section at the top of the screen. There's a little icon that says Q&A. Please post in those. Please don't use the chat to post your questions. All Q&A will be at the end of each presentation, as I said. Today, the materials are being recorded, and the slides are being recorded, and at the end, we will share them online, and if you request, we can send them to you. Today's presenter will be Corey Johnson, as I explained earlier. Corey has 14 years in the dimensional engineering industry. He specializes in body-white automotive modeling, and he works with customers on gap and flush, fit and finish for complete vehicle stack-ups. So with that, our first enhancement for the 8.3 is Drive to Nominal. Drive to Nominal is one of our new 3DCS capabilities that calculates the exact locator adjustments that need to bring drifting assemblies back to a nominal target. It replaces the trial and error of a data-driven correction plan. So, move on. One of the most common challenges in the manufacturing process is not predicting the variation, but it's know what to do when variation occurs. Even when a robust process assemblies drift away from their intended nominal condition due to tool wear, fixture movement, and supplier variation, material changes and nominal processes variation moves. Tool wear can cause processes to drift away and give us hard times figuring out where to adjust a locator, in which locators to adjust, and how many locators to adjust. With Drive to Nominal, we can eliminate the guessing and give you more direction of where to go. Come on. The solution. So basically, Drive to Nominal is a new capability within 3DCS that transforms dimensional analysis into actionable product guidance. Using 3DCS variation model, your 3DCS variation model, simply enter the current measured means of your assembly. Drive to Nominal identifies which locators are driving dimensional deviation, calculates the minimum number of locator adjustments required, determines exactly how much each locator should move, and predicts the outcome before a single fixture is adjusted. Instead of asking, what should we try next, your team can confidently answer, here's exactly what needs to change. So with all that being said, let's take a look and see how Drive to Nominal looks in action. Corey, please take it away.
Thanks, Steve. Hello, everyone. My name is Corey Johnson. I'm an applications engineer with Metrologic DCS, and I'm going to be walking you through the new Drive to Nominal tool that we have. The DTN tool is a new feature within 3DCS used to determine an optimized shimming combination for any part or assembly that you have that is located to a tool or fixture. The optimized shimming combination is determined by utilizing a genetic algorithm that we've developed that evaluates the mean shifts of your measurements in combination or correlation with your geofactors from each tooling location. The algorithm then uses that information to calculate how many locations need to be shimmed and by what value. So you can just see in the graphic here to the right, circled in red are all the tooling locations, a combination of fixture pads and a couple of fixture pins. And once you load your mean shift data, which I'll get to in the model, it's going to reference that mean shift data relative to your measurements and figure out which one of these locations circled in red need to be shimmed and by what value. So where to find the Drive to Nominal tool? The button can be seen here on the right, and it currently resides in the 3DCS add-ons toolbar. As I'm doing this demo, this is the first release of this tool. So it currently resides in the add-ons toolbar, but just worth noting that in future releases, it will be moved to the main 3DCS Variation Analyst VA toolbar. So let's jump into the model and take a look. Okay, so I have a pretty basic 3-part or 3-assembly model here. We got a door ring and a front and a rear door. We'll just walk through the animation really quick. We got a door ring going to a tool, as well as the rear door and then the front door. And those are set up using these 3 moves here. So we'll close out of that and separate. And we'll take a look at the measurements really quick. So I'll zoom in on one of these. These are just basic gap and flush measurements. These ones are the front door to the rear door. And then I also have some on the rear door to the door ring, gap and flush, top and bottom, as well as a couple here at the front of the front door. Now, this is what we'll call the base model. So I have my moves, and I have my gap profiles, flush profile tolerances, and all the other relevant part tolerances relevant to the stack up, right? So this is just my rigid analysis model. To utilize the DTN function, what you need to do is create a tolerance for each point that represents a fixture point, whether it be a fixture pad or pin, and just add a tolerance to that point in the direction it controls. So I'm going to hide the door stuff for a second and show you what I mean. And let's just pick up on, let's say, this one down here. So I'll go zoom in down here. So I got a point here in the middle of that fixture pad. And you'll notice if I zoom in over here and I get kind of a side profile view, I highlight that A5 and you can see that little arrow highlight, just a point in the direction that pad controls. And then likewise, if I scroll up here to this pin controls X and Z. So I have a separate X tolerance and Z tolerance. So pretty simple, just a point on each fixture point location. You just need to add a tolerance in each direction that it controls. Now, like I said, this is my rigid analysis model, and you can see all these fixture, or we'll call them shim tolerances, are all deactivated. What I did is I utilized our model variants. You can see I'm currently in the base model. And what I'm going to do is apply my DTN shim variant. And what that's going to do once I hit apply, as you'll see, is deactivate all the part tolerances and every other tolerance in the model. And it's only going to leave my shim tolerances active. So now every other tolerance in the model is deactivated, except for my shim tols that you can see now are no longer grayed out and are being used in the model. One thing worth noting, if I open up one of these tolerances, every tolerance has a value. I just stuck with the default of 1 millimeter. The tolerance value is more or less irrelevant for the DTN function. It's really just there to calculate geofactor. That's the only thing that the DTN tool is going to reference. The value is not going to matter. So this could be 0.1, it could be 1, it could be 10. It doesn't really matter. So I'm going to close that out. I'm going to now show the whole model. And now we are going to run. Now this is an important step because you need to run this model with these shim tolerances, and this is how you get the geofactor that the DTN is going to utilize. So I got my results. I'm just going to kind of move it up here for a second. And now I am going to go to my 3DCS add-ons and over here to drive to nominal. So let's take a second and talk about what we're looking at here. I'm going to expand some stuff out. On the left, we have all of our measurements. We can see with a spec limit of ±1. And on the right, you have all of your shimming locations. And the default shim size, which I'll get to in a second. So measurements on the left, shims on the right, or your tooling locations on the right. Now, what you have to do is import your mean shift data for the algorithm or the optimization to run. And for this example, what I have created is just a basic table of mean shifts. Worth noting, like this, you can get this data from, just plant data, or this could also be, you can bring in your QDM data if you have that. So what I'm going to do is just copy all of these mean shifts for my measurements, and I'm going to paste them right here into the mean shift column. Now, you see, once I did that, if I zoom or expand this way out, a couple of them are flagged yellow. Now, these are flagged yellow because these mean shifts exceed the spec limits right here of ±1. So those obviously need to get addressed because you're going to need to shim there to get that within spec. So what I'm going to do, and now I've played with this model a little bit, and I've determined that a shim increment of 0.5 millimeters is best. But regardless, whatever shim packs you have, whatever shim increment you would do, in the real world on the plant floor, you can edit that by just, I'm going to click here in this where it says plus 0.25, and this dialog box immediately comes up. I'm just going to switch that from 0.25 to 5. Now, once I do that, worth noting that once I hit this optimization, this adjusted mean, right now it's a 1-to-1 ratio. You got mean shift and adjusted mean shift. They're the same values right now because I haven't optimized yet. But once I optimize it, it is going to refer to the geofactor and these tooling locations, figure out which ones need to be shimmed by what value to get these mean shifts closer to 0. It's not going to try to get it into the goalposts of the upper and lower spec limit. It's going to try to go to 0 or closest to nominal as possible. But once you have this set up, you can simply hit run optimization, and you can see these values changed. I got no more yellow, and these values are much closer to 0 now. Now on the right, you can see the shim change. You can see I got a -4, a -2, a +5. So it will tell you the direction also that you need to shim. And also worth noting is that the algorithm is going to determine, it's going to try to solve by figuring out the least amount of shim changes needed. So just worth noting on that. And then now you can use this information and kind of transfer that or relay the information down to the plant floor. One thing that I will notice before I go is this lock tool, this lock column, I'm sorry. So right now there's no reset button. There will be one, but for now I just have to close out of this and just reopen. And I'm just going to simply put this same information back in there, 0.5. Now this lock function is for some tooling locations you know you cannot adjust at that specific pin location or fixture pad location. And if that's the case, you can simply, I'm just going to pick a couple random ones. You can say lock these two locations. Hey, I can't adjust there. Now solve if I can't adjust at those locations. And then just run the optimize again. So if you need to utilize that function, that's where it's at. If you have those, we'll say limitations. But other than that, that is the DTN tool. I thank you for your time, and I'm going to turn it back over to Steve.
Turn the mic back on. All right. Well, thank you very much, Corey. At this time, I'd kind of like to open it up and start taking any questions before we start walking into Copilot. So let's take a look. Looks like we have a question here from Jeff Davidson. Shim change is quantity of 0.5 shims. Kind of.
Where the question has to do with Jeff Davidson's asking, he says shim change is quantity of 0.5 shims. And this has to do with what is the shim change column really telling us? And that is related to that shim value that you set in your demonstration, remember?
Correct. Yeah. So whatever your shim increment is, the value of shim changes, you would effectively just multiply the increment by the number of shim changes. So in my example, if I am shimming in increments of 0.5 and it recommends 3 shims positive, that would be 3 times 0.5, so a 1.5 millimeter total shim change.
Martin Roth asks, are there further options to set conditions for the shimming, e.g. only positive shimming for individual locators? So that'd be like an area where we have no shims, so we could really only add shims at that location. We could not remove shims at that location.
That is a good question. Spencer, I believe so, but that would you would have to take care of that in the tolerance, correct? That you add to that specific point?
Yeah, so I guess unfortunately right now there really is no way to have like an add only or remove only section for a shim. We assume that you could add or remove as many shims up to the maximum value that you actually can set. So you could set it to be like 5, which means that you can add or remove 5 shims from any location, but that is assuming that we can add or remove shims from all of the locations. So that's a good question and perhaps something for our team to discuss.
Yeah. Yeah, because that does come up in the real world where they can only go one way. So that is an enhancement we can add in the future. I'm sure that's doable.
All right, Woody asks, so if I understand this correctly, does DTN translate and orient the door to minimize the mean shift at every location?
It is not going to translate the physical CAD. It is using your move operations, how you locate each part or assembly to the tool to pick up the geometric effect as you locate to all of those tooling locations, and then references the measurements, your system of measurements, to figure out which ones you need to shim to get closest to nominal. You're never going to get to completely nominal, but it is not physically translating or adjusting the CAD in real time or anything like that.
Yeah, I think when you apply the recommendations, drive to nominal gives you the door will translate, orient, rotate, whatever it has to do to close those gaps. But drive to nominal is inherently not graphical. It just kind of lives in that dialogue that Corey was showing. So
yeah,
what do you conceptually, you're correct on this, but when 3DCS is executing it, it won't show any of that.
Yeah, visually you're just not going to see it.
Exactly. Do we have another question? Yeah, we have another question. Does this tool support four-way locators, location and or size?
Yes. Yeah, I have in my tool, I have three parts. I have the door ring, the front door, and the rear door. All three of those subassemblies, we'll call them, locate with a combination of fixture pads and two tooling pins, one four-way, one two-way locator. You simply, so for a four-way locator, you would have to have a tolerance in both directions it controls. And then likewise for the two-way locator, it's a slot, a pin going into a slot. You just need a tolerance going in that one direction, the controlling direction of that slot.
Yep. And then Woody has one more question here. He says, in case of interference, assuming that's what AV mean shift is, does that mean material needs to be removed from the part or the fixture at that locator? I guess I view adding or removing the shims as a negative. Got it. Thank you, Woody. A negative means, yeah, a negative in that column would mean that you have to remove shims from that location, versus a positive in that shim change column would mean you have to add shims to that location to the fixture. So that's what it's telling you, which in effect is adding material, I suppose, to the fixture, but it's in the form of these shims that are incremented, as Corey mentioned.
Right. The shim's not the part itself. We don't want to start cutting parts and making parts thinner or bigger. That's not. It's the shims. The value of increment is for the shims, whether it be positive or negative.
Martin Roth asks, did I get it right that the objective in the optimization is to minimize both the number of shims and to get it close to nominal?
Correct. It's going to reference your measurements, and this in the spec limits, as I mentioned, are kind of irrelevant because the goal is to drive to nominal, right? So whatever that mean shift is, it's going to calculate the fewest amount of shim changes needed to get that mean shift or that measurement location closest to nominal as possible. And it's not just for one specific measurement, it's all the measurements, it's the system of measurements that you have in your model. So you could theoretically, I kind of thought about this after the fact, you could do this for a whole subsystem, but you could also kind of hone in on maybe one subsystem, maybe one critical area, deactivate all of your measurements, and kind of problem solve for a specific interface, if you will. And you would just do that. What it's only going to solve for the measurements that are active that were ran in the initial model when I ran the simulation. So it's going to figure it out whatever ones are active there. So you can do it for the whole system, or you could kind of narrow your adjustments or your potential for needed adjustments by deactivating all the measurements you don't care about.
And then Martin also kind of asked in the back end there, I guess it is a weighted single objective optimization problem. If so, do you plan to make it a bit more open to change weightings? I can answer that one. We had a lot of discussions with the development team about what the objective function could be, which is honestly a longer conversation. And I know they're still discussing exactly what the how open it should be. You are able to play with the genetic algorithms parameters to determine how, or I guess when it will optimize, but not so much on like the weightings of what it prioritizes, be it, number of shims we add versus how close we get to nominal, for example, which is kind of how I'm reading your question, Martin. So that's kind of something we're still discussing. I think I'll do one more question, and then we'll hop into the next section to make sure we have enough time. Jeff Davidson asked, does DTN work with features or just points?
It would work. It would work either way as long as you're utilizing points. They can be coordinate points, DCS points, or feature points. But it needs a specific XYZ location. But whether or not that point is in a coordinate point not tied to a feature, or if you're using feature points, it'll work the same either way.
Yeah, it needs to know exactly where the shim is being put, so that we know exactly the impact the shim is going to have. If we were given an entire feature, we don't totally know where on that feature the shim would be, and that's where kind of the necessity of a point location comes. And all right, I'm going to wrap up this Q&A. We did have one more question, but we can save that, and if we have time after, we can address it. And I'm going to toss it back to you, Steve, to get going on the next section.
All right, thanks. I appreciate that. So with that, let's move on to the next addition to the 3DCS, which is going to be the Copilot. I'm going to turn my camera off. So the next new feature we've added is the 3DCS Copilot, which I'm pretty excited to introduce. So again, every engineer has experienced it. You're in the middle of building a model, analyzing results, and you need to remember how a particular function works, where to find a specific workflow, or the best approach to solving a problem. Traditionally, it meant stopping your work and searching through files, training documents, white papers, videos, whatever. Copilot hopefully is going to change that. It's going to bring knowledge directly to you, providing instant access to trusted dimensional engineering expertise without ever leaving your 3DCS workflow. So our vision for AI goes beyond helping engineers find next information. The next step is helping engineers make better engineering decisions. Copilot is designed to work the way engineers naturally think. Instead of navigating menus or remembering exact terminology, you simply ask your question in your plain language. Just ask as you would ask a colleague sitting next to you. Behind the scenes, Copilot searches approved 3DCS documentation, help manuals, white papers, blogs, training materials, educational resources to deliver accurate, trusted answers, not information pulled from the open internet. Because it's integrated directly into 3DCS, the guidance appears exactly where you're working, allowing you to stay focused on engineering instead of searching for information. Again, so the real impact is the values of Copilot is immediate. Basically, your new users can become productive in days instead of months because guidance is available at the moment they need it. Experienced users can spend less time searching for documentation or contacting support, reducing the burden on internal experts and allowing them to focus on higher value in engineering work. And perhaps the most importantly, organizations see greater return on their software investment because engineers discover and begin using powerful 3DCS capabilities they may have not realized were available. This is just the first step on our AI journey, but it's one that delivers measurable value from day one. So again, with that, I'm going to turn it over to Corey and we can start seeing some of this in action.
Hello again, everyone. I'm going to be walking you through the new 3DCS Copilot. So here at DCS, we've developed interactive AI chat that you can use to hopefully answer any modeling questions or any questions you have about the software. And right off the bat, this is worth noting for anybody that may be concerned, 3DCS Copilot is not reading or being trained on any personal data. Copilot references internal DCS documentation only to answer your questions. Now, the Copilot tool can be found in the main 3DCS VA toolbar here, and the icon looks like this. So let's jump right into the model and give it a test. So here I'm in my main toolbar. I'm just gonna toggle all the way over here to my Copilot and open that up. And down here at the bottom, I'm going to ask my first question. I'm going to say, how do I set up a 6-plane move? And Copilot's going to think. And it's going to give me my answer. So you got some graphics down here and then an explanation up here. Now, I'm going to ask a follow-up question. Maybe let's do the directions. Maybe how to define each direction for the 6-plane move. It's actually an option here, or you could just type it in. But since it's an option, I'm just going to select that and hit enter. There we go. We got the same graphic because it's still referencing the same 6-plane move, but the answer to your question is right here in the verbiage up top. And it tells you how to define the directions for your 6-plane move. Now, a couple other quick things. You can see here in this left window, you can kind of expand or minimize. This is your search history. So every question that you ask, it'll be kind of logged here, and you can kind of go back into it as you ask questions. If you need to kind of go back to reference a question that you already asked, you don't have to type it again. So I'll minimize that. Also, if you want to switch topics or ask it a different question, you can just hit this new chat button and kind of start over there. The only other thing that we ask is that if you are using the Copilot is to give it feedback. So we have this, was this answer helpful option here. Simple, green thumb for a good response. It answered your questions, and a thumbs down if it did not. And that'll do it for Copilot. And I thank you all for your time.
All right, thanks, Corey. And that one was kind of short and sweet, but yeah, we can move on to Q&A and anything going with Copilot if anybody has questions with that.